We're going to go through a proof today involving the scale factors of perimeters of similar triangles. So if two polygons are similar, then their perimeters will be proportional to their sides. To start off the proof, we're going to be given that we have a pair of similar triangles, ABC and DEF, and we have a ratio of corresponding sides, AB to DE is equal to m over n. This will establish some variables for us to use throughout the proof. We want to prove that the perimeter of triangle ABC to the perimeter of DEF is also equal to m over n. We're going to prove this by manipulating an equation to become the proof statement. So let's start with what we know so far. We know the triangles are similar, okay? That means the corresponding angles are congruent and the corresponding sides are proportional. If the sides are proportional, then there must be a scale factor. m over n in this case will be the scale factor. That means m over n also equals the ratio of the other corresponding sides, BC over EF and AC over DF. Those are the common scale factors. Because the sides are proportional, those ratios must be equal to the scale factor as well. So let's establish what we know so far. We've got our givens rewritten. We've got two more scale factors, courtesy of the definition of similarity. Let's explore those statements. Each of those equations can be manipulated, so we isolate sides AB, BC, and AC. We can multiply by the denominator on both sides of each separate equation. So the first one will multiply by DE on both sides, then EF, then DF. That'll be helpful because I'm eliminating my denominator on the left-hand side and I'm isolating those side lengths AB, BC, and AC. I have these new equations now that we're going to save for later. AB equals a value, BC equals a value, AC equals its own value. Let's throw that into the proof and we'll save it for later. We multiplied on both sides, we're allowed to do that. But isn't this supposed to be about perimeter? Yes. Let's start to include that now. We'll take that route. So we know how to find perimeter. It's the sum of all sides of the triangle, or any shape in general. So the perimeter of triangle DEF will be the sum of DE plus EF plus DF. Same for the perimeter of ABC. We have AB plus BC plus AC. That's the definition of perimeter. That's how we establish the equation. But that's interesting. Okay. This could be useful. I'm seeing AB, BC, and AC pop up again. So I isolated those sides earlier because I wanted to use them later on. Now I can do a quick substitution. I know the values of AB, BC, and AC. I can substitute what they're equal to into this equation directly. And from here on out, I'm only going to work with this equation. So I've substituted these values in, and conveniently, they all happen to have m over n in common. So let's factor that out. That gives me m over n times the sum of DE plus EF plus DF. Conveniently, that should look familiar, because it is familiar. We're going to use that term as well and do another substitution. So now instead of DE plus EF plus DF, I can substitute that as the perimeter of triangle DEF itself. So this is where I'm at so far. I've got that the perimeter of ABC equals m over n times the perimeter of DE, triangle DEF. Quick reminder of what we're trying to prove. We want the ratio of ABC over DEF to equal m over n. We're almost there. This is where we're at right now. We can get a ratio of ABC to DEF if we divide by the perimeter of DEF on both sides. That gets us the exact ratio we need, equal to m over n. So to sum it up, this is what our proof looks like in conclusion. We did some substitution, a little factoring out of a GCF, substitution again, and we manipulated the equation of perimeter to turn into the proportion that we needed. This justifies and proves that the perimeter of similar triangles is equal to the same scale factor as the corresponding sides.